Chapter 1, Section 3 is about real numbers and the number line. By the end of this lesson, you should be able to classify real numbers as rational, irrational, whole, and natural. You should be able to order and compare these real numbers, and you should be able to simplify and estimate square roots. Your first vocab word is square root, actually. A square root is a number. What number times itself would give you the number under the sign. Okay, a square root is written with this little sign right here. This is called a radical, and the number underneath is the one you're looking to create. The radicand is the expression that's under the radical sign. These are examples of square root expressions. Perfect roots are ones that have non-decimal square roots. For example, all of these below. So what we're looking for is to see what number times itself is going to give us 64. Okay, well, because 8 times 8 equals 64, that means our answer for the square root of 64 is just 8. We don't write 8 squared and we don't write 8 twice. We just say that 8 is the square root. For letter B, we're looking for what number times itself equals 25. That happens to be 5. Okay, when you get to a fraction, it's almost like taking the square root of the number on top and then the square root of the number on the bottom. So the square root of 1 is just 1, and the square root of 36 is 6. So therefore, the square root of 1/36 is 1/6. Okay, letter D, same idea. The square root of 81 is 9, and the square root of 121 is 11. So as a fraction, we just say the square root of 81 121sts is 9/11. A perfect square is the square of an integer. So for example, if I started with 1 times 1, that gives me 1. The next whole number would be 2 times 2, which gives me 4. 3 times 3 gives me 9. So these three numbers are called perfect roots. Okay, if the radicand is not a perfect square, then you have to estimate, which gets a little bit messier. In your notes, there should be a place for you to write down the first 15 perfect squares. I had them started back here for you. I need you to continue with 4 times 4, 5 times 5, all the way until you get to 15 times 15, just so that you have that as a reference. Okay. When you're estimating square roots, we just want you to figure out which one it's closest to. Okay, so we're trying to figure out where the square root of 52 falls. If you look back at your 15 perfect squares, you should be able to see that the square root of 52 falls somewhere between the square root of 49 and the square root of 64. Okay, well, the square root of 49 is 7 and the square root of 64 is 8. So we're going to choose which one it's closer to. 52 is actually closer to 49, so we would say that it is about 7, even though we know it's just a little bit higher. For the square root of 106, looking on your chart, that falls between the square root of 100, which is 10, and the square root of 121, which is 11. Again, it's closer to this smaller one, so we would say that it's about 10. 217 falls in between 196, which is 14, and 225, which is 15. This time, 217 actually falls closer to the larger one, so we would say that it's about 15. What is the approximate side length of a square that has an area of 220 square inches? In order to figure this one out, we have to remember how you find the area of a square. If you remember that a square has the same distance on all four sides, and to find the area, I would multiply those two sides together. If both sides are the same, then that would be the same as finding the square root. Okay, so we're really looking for the square root of 220 inches. Well, this one's not a perfect root, but we can figure out what it falls in between. If we remember, go back to our perfect root chart, the square root of 225 is 15, and the square root of 196 is 14. This one happens to be closer to 15, so we could say that the approximate side length is about 15 inches. We know that it's actually going to be a little bit less, but they asked for approximate. All right, now we have a couple of vocab words for you. An inequality is a symbol that compares two expressions using one of these symbols, depending on the situation. This one, with the smaller side coming first, is less than. Open side first is greater than. And if it has a bar underneath the bottom, that means it could be less than or equal, or greater than or equal. We're going to use those symbols to compare these two numbers. We need to try to figure out what is the inequality that compares the square root of 34 and the number 5 4/5. Okay, the square root of 34 is somewhere in between 5 and 6. Definitely closer to 6. So we know it's 5 point something. Well, 5 4/5 is 5.8. So we need maybe to double check on a calculator to find the square root of 34, just to be sure, since we know they're pretty close. 5.83 happens to be the square root of 34 if we round it. So if I'm going to use an inequality symbol, I'm actually going to say that the square root of 34 is greater than 5 4/5. Okay, same here. An inequality that compares the square root of 129 and 11.52. Okay, first, before we check anything on a calculator, we're going to try to figure out the approximate square root of 129. Okay, the square root of 121 is 11. And then if we go all the way up to 12, that would be the square root of 144. So we know it falls between 11 and 12, definitely closer to 11. So it's 11 point something. If I check with my calculator, I actually get that the square root of 129 is 11.36, and we're comparing that to 11.52. So we're going to choose the less than symbol this time. Okay. The last thing that you're going to have to be able to do today is put real numbers in order: square roots, fractions, decimals, negatives, positives. So we're going to decide out of this bunch of numbers which one is least all the way up to greatest. Okay, so the first thing that we know is anything negative has to be smallest. Okay, negative 2/3 is like a negative 0.6 repeating. And then we have negative 1.5. The one that's most negative out of those two is the negative 1.5. So when we look at our multiple choice, our first number has to be negative 1.5. Otherwise, they did not start with the smallest number. So that means we can already get rid of A. We can already get rid of D. Okay. Well, the next biggest number, or next smallest, I guess, has to be the negative 2/3, because that was the only other negative option, which means this one is also out. And C would be our answer. Okay, they want these graphed on a number line, which will then put them in order from least to greatest for you. Okay, so one thing that you're going to have to do is you're going to have to draw your number line. But before we put numbers on it, we're going to have to know what we need. The smallest number that we have a negative 2.1, and 7 over 2 is actually 3.5. So we have negative 3.5. That looks like the smallest we're going to have to go. And let's see, if we figure out the square root of 9 is 3, the square root of 5 is not a perfect one, but it's about 2.24. Okay, so if we put these on our number line, I'm going to put a 0 here, a 1, a 2, a 3, we'll pretend that's a 4. Looks like the biggest number that we're going to need is 3.5, positive. Okay, and then we're going to put dots on our number line where these numbers actually fall. Okay, so 3.5 falls right in here in the middle of 3 and 4 on the positive end. Then we have negative 2.1, so that should be pretty close to negative 2. We have this, oh, we should label these. Then we have the square root of 9, which is actually a positive 3. We have negative 7 over 2, which is negative 3.5. And last but not least, we have a positive square root of 5, which we discovered was 2.24. Done. Once they're on a number line, they are already in order from least to greatest. So now you can just write them out to answer their final question. We have negative 7 over 2, negative 2.1, square root of 5, square root of 9, and 3.5 from least to greatest. Okay, this is a 2-day lesson, so this is your full assignment. But what we talked about today are numbers 10 through 26 even, 38 through 50 even, and then numbers 1, 2, 4, and 5 on your lesson quiz.